Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about area, volume and measurement. Now the question I'm going through here is 2018 paper 2 question 5. In this question we're given the square ABCD and we're given the square PQ or S. The second square is inside the first square. Now obviously remember, if we're dealing with the square, all of the lengths are the same. The length and the width is the same thing. They've told me that the distance from A to Q is 5 and the distance from A to B is 7. So obviously that means the distance from Q to B is 2. So by extension then I know that the distance from B to OR is 5, OR to C is 2, that one's 5, this one is 2, that's 5 and this one is 2. So I know all those measurements along the outside. The question here is to find the area of the square PQ or S. In order to get the area of a square, it's just the length multiplied by the width. But if it's a square, the length and the width are the same thing. So if I can just get one of the lengths, then I'll be able to get the area. So the first thing you need to do here is look at the triangle PAQ. It's clearly a right angle triangle because the corner of a square is going to be 90 degrees. You know two sides in the triangle, so you can use Pythagoras' theorem to get the third side. If I'm using Pythagoras, it's a squared equals b squared plus c squared, where a squared is the hypotenuse, or in other words, the side opposite the right angle. In this case, if I was using the triangle PAQ, if I subbed into Pythagoras, I could say that PQ squared is equal to AQ squared plus AP squared. Now this is going to be relatively easy because the only one there that I don't know is PQ. So PQ squared must be equal to AQ squared, which is actually 5 squared, plus AP squared, which is actually 2 squared. So happy days, I can say that PQ to be squared is equal to 25 plus 4. So in that case, that means that PQ squared is equal to 29. Obviously, I don't want PQ squared, I just want the distance PQ. So I can say that the distance PQ is the square root of 29. So the distance PQ there is root 29, which means that all of these distances are root 29. All 4 of those distances are root 29. Now the question is to get the area of this square. And in order to get the area of a square, it's just the length multiplied by the width. So the length multiplied by the width in this case would just be the square root of 29 multiplied by the square root of 29. Square root of 29 by the square root of 29, that's the same as root 29 squared. The squared and the square root cancel each other out, or if you just plug that into your calculator, you'd end up with 29. So you know that now the units we're using in this question is centimeters, and it's area, and area is always squared. So your final answer should be that the area of PQ or S is 29 centimeters squared. Okay, so for the second part of this question, we're introduced to 2 different circles. The circle U with a radius of 4 centimeters, the circle V with a radius of 6 centimeters. We're asked to find the circumference of each circle. So in order to get the circumference of a circle, the formula is on page 8 in the log tables. And it says L, which stands for the circumference, is equal to 2 pi OR, where OR is the radius. So if I'm getting the area, or the circumference, sorry, of the big circle V, then I'm subbing into 2 pi OR, where the radius of V is 6. So it just becomes 2 pi multiplied by 6. And it asks you to leave your answer in terms of pi. So 2 multiplied by 6 just gives you 12 pi. And the circumference is a distance. So it's centimeters. It just remains as centimeters. It's not squared or it's not cubed because it's only a distance. You do the same thing with the smaller circle U. You're subbing into 2 pi OR, except instead of the radius, instead of OR, you can sub in 4. 4 by 2 gives you 8 pi centimeters. So your 2 answers for part B were 12 pi centimeters and 8 pi centimeters. Okay, so for the final part of this question, we're told that as one wheel rotates, the other one rotates as well. For every once that wheel U rotates, it travels 12 pi. For every once that wheel U rotates, it travels 8 pi. And I'm being told that wheel V is going to travel 100 times. It's going to rotate 100 times. So 12 pi multiplied by 100, that means that the distance wheel V is traveling is 1200 pi, which obviously means that the wheel U is traveling that distance as well. I know that one rotation of U is 8 pi centimeters. So if I divide one rotation into the total distance, one rotation of u into 1200 pi. That tells me that in order for u to travel 1200 pi, it would need to rotate 150 times. And that's your final answer for that bit. I hope that video makes sense. If there's anything you're unsure of there, then send me an email or let me know in class and I'll try and explain it a little bit differently.